Hi, thank you for coming. This is a workshop about Gander, the performance testing framework that we've created for Drupal. The idea of the workshop is that you guys do like hands-on work, which we will lead you through. If you don't want to do that and you just want to sit and listen, that's also fine. But yeah, at the end of the workshop, you will have an environment where you will be able to run performance tests for Drupal core. You will learn how to write these tests, and ideally we will add a few tests to core and submit merge requests. Let's see how that goes. This is the URL to the slides. You will need that because we have steps on the slides, and it will be easier for you to just copy paste into the terminal instead of like writing everything from the screen. And the QR code appears after a few slides as well, so if you miss it now, you will have another opportunity. We are Janez and Nat. We're both at Tag1 Consulting. Tag1 Consulting is a company that specializes in performance, so this is a natural kind of work for us. We are also one of the biggest contributors to Drupal as a company, and both Nat and I also as individuals. So yeah, I used to be the lead of Drupal Core Media Initiative and worked at examiner.com, which used to be the biggest Drupal website on the internet at the time, which is where I first really got interested in performance and also learned a lot.
Yeah, so I'm Nat Catchpole. I've been working at Tag1 for about 15 years. And yeah, mostly performance audits and things like that. And I also the other half time I'm a Drupal core committer framework manager as well.
And he created Gander, which is the tool that we are showing you today. A few words about Tag1. We are the second all-time contributor to Drupal, and we have the largest concentration of core contributors of any organization in the community, and we donate a full-time infra expert to Drupal Association. So if you use issue queues, if you ever went to Drupal.org, this is what we help run. We work with enterprise clients from many areas, and in enterprise world, performance often comes up. The QR code and the link again. If somebody misses it, just let us know, and we can also do it later. So a few words about Gander and history and why we've done it. First, why are we even thinking about performance? The main reason is that slow websites turn away users, which in turn reduces your reach, your revenue, your profit, whatever it is you wanted to achieve with the website. Also, the performance is a factor for search engines when they are ranking your site. So a slower website will generate less traffic. And a real life example would be like, do you like to stand in a line at a bank? No. So why would we make our users do the same? The problem with performance is that if it is neglected, which it often is, it becomes really hard to solve when problems pile up. It's really worth thinking about it from the beginning, but often that is hard to justify, so that doesn't happen. If performance is neglected, it can lead to availability issues, which is then the worst outcome. Traditionally, we thought about performance mostly in context of time to first byte, which is backend performance. But nowadays, with a lot of front-end code and a lot of interactivity and all that, front-end is becoming more and more important. So we have to think about both aspects. And Gander does measure, things on both ends of the spectrum. And at the end of the day, slow websites generally consume more CPU power, which then in turn consumes more energy, which is worse for the environment. So if you take care about performance, you're doing good work for the environment as well. Nat already mentioned performance audits. These are like one type of the projects that we do. Clients approach us when they have performance problems and then ask us to analyze their site and figure out what the problem is and how to fix it. Usually it happens way too late when there are way too many problems. But we also see most common problems are usually present on all audits that we have. And these are like caching problems, misconfigured views, like excessive use of contributed modules. We're talking like hundreds. And common problem, but like a bigger problem to fix is a team culture. If the team culture does not include thinking about performance, reviewing it, and things like that, then this can lead to actual performance problems over time. We created Gander together with Google Chrome team. They approached us a while ago, about 2 years ago. They want to make internet faster, and they decided to work with open source platforms to have the biggest reach. And initially, we contributed some features to core, specifically lazy loading of images and iframe embeds. And then after that, we decided we want to do more, and we were thinking about what could be the next step, and we decided to do performance testing. And this is how Gander was born. And if we go back 15 years, this Mr. here opened an issue about adding automated performance testing to core in 2009. And so many years later, the same Mr. led the effort and designed the whole system, and now we finally have it. And this issue is now actually closed, is it?
Yeah, I actually closed it out, yeah.
When we were considering doing this, we understood that it's a long-term investment. It will take a while to see real benefits, but we thought that it's worth it because before Gander, performance testing in Drupal was done manually and by people that are already overworked, so it was only done occasionally. And even bigger problem was that we didn't have any consistent testing. So every time the results were different and we couldn't compare apples to apples. And issues were often detected only when somebody noticed it on a production website, which is not great. Automated performance testing fixes all of those problems, but it's a quite big investment because we need to learn to use it, then we need to develop habits to use it. But if somebody would tell us to develop core without functional testing at all, which used to be done, we couldn't imagine it. And we hope that it will be the same with performance testing. Drupal core already uses it. It can be used in two ways. We'll show you later how. It can be used to assert on performance metrics when you write a test, and you can also have certain tests that you run regularly, and then you send metrics to a dashboard where you can observe the long trends. And we are running it this way. Assertions are part of the normal test suite now. So if you have performance assertions and something bad happens, like the normal test suite will fail. But we are also running it regularly, and on gander.tag1.io, you can see the dashboard for core. And today you will learn how you can start using it on your project. This is how the dashboard looks, the one for the long-term statistics. And Gander is not really old, but it already brought a lot of improvements to core. The biggest one improved the core test suite runs by 10%, which is huge considering how many test runs we have on a daily basis. So just with this improvement, it basically paid for itself. But we keep identifying more and more things that can be improved and adding performance stats for them so they are not reintroduced. Yeah, those are some of the issues. So what is Gander? It's basically a base test class that is in core since 10.2. It's a special type of JavaScript functional test. So in practice, not in theory, any functional JavaScript test can be converted to a performance test. And it's currently measuring these metrics that are on the screen. And then you can assert on these metrics after you've navigated the site and did whatever you were doing. This is roughly how it looks for those of you who are familiar with tests in Drupal. We'll see like the Drupal get calls should be very familiar. And the first two lines are what we call preparation, where you prepare the environment for the test, usually warm up the caches or prepare some content. And then everything that you want to collect performance metrics for is done in the collect performance data closure. And everything that will be done inside of that performance metrics will be collected for it and then returned as this performance data class that you can see we're then asserting on at a later point. So let's start using it. We said that we will do a little show of hands. Anyone already tried using Gander? Okay. Who of you is familiar with like Drupal testing in general? Like try to run tests, write them. Okay, cool. How many of you have ever contributed a core patch? Okay, awesome. How many of you already have like a working local environment for Drupal core where you can run tests? Okay. So for those of you, like, how many of you are using DDev? Okay, so it's probably the intersection is probably quite big, but nonetheless, in this workshop we will be using DDev because this is what we use and this is what the official Gander documentation also suggests. But you don't need to use it. It will be just impossible for us to help you. If you're using some other environment, the requirement is that you are able to run JavaScript tests, and then you should be able to write Gander tests. Prerequisites for the workshop today is to have DDev installed and Composer installed on your machine. If you don't have it, please start to do it now. And we have a few people here in the room that are here to help you. So if you, along the way, not just installing like these things, if you run into problems, just raise your hand or shout and somebody will come to you and help you. At the end, as I mentioned, we will be writing performance tests and hopefully submitting merge requests for core. The problem is that we don't have as many issues as there are people in the room, because honestly, we were not expecting you to be this many. So we were thinking that maybe we would then, when we will be doing that we will be doing it in groups, like with a few people that are sitting around you. You could work on a given issue and then review each other's work, and because otherwise there won't be enough issues for everybody. So this is the first step in the workshop. It's basically creating a new environment. If you already have an environment, you can use that. But if you don't, or if you don't want to pollute it with this stuff, you can just create a new environment. This is based on the docs that are on Drupal Wiki. This is this page. It has a lot of information about Gander and what it does and how to contribute to it. And what we're doing today is taken from the quick start section. So you can always refer back to that if you need to. With a slight twist, like the quick start section is using Composer project to bring up the environment. Since we will be contributing to core today, using Composer project would make that a little bit harder, because it's hard to create a merge request. And for that reason, we will be using git clone instead. But it's very similar. It's the way how you get things is different, and the folder structure is a little bit different, but everything else should be the same. So yeah, let's do it. Another thing, if you don't have DDev and you are concerned about polluting your machine, there is a slide at the end that will basically remove everything from that you've done, and there should be no trace at the end, if that's a concern. So let's do it. Whoops. I will sit down because otherwise it will be harder for me. I apologize. So let's. Hold the mic down. Yes, thank you. It's fine. Okay. Why do you Composer and not DDev Composer? Does it make a difference? No, it doesn't make a difference. So as you can see here, when I install Drush, I'm using DDev Composer. Here I'm using it on a host just because DDev is not configured yet and it's not running yet, so that won't work. But no, it doesn't make any difference, I think. So we're cloning core. I hope that we won't flood Wi-Fi now, because we're all doing it. Huh? Okay. Should have left the one that I had before. Okay, well, any questions so far? The issue queue. It's a few slides down. It's this slide, write test yourself. This is the meta issue. It's really slow. What if I tether? Yes, something like that.
If you really want to work on an issue and you don't want to work on the same issues as everyone else, if you can think of something, you're welcome to add a child issue of your own devising, and you could the bottom three are examples of things that you would be able to come up with your own idea. But also, if like 5 people work on the same issue, you can review each other's MRs and then RTPC them, and get it committed. So either way, it should or hopefully work.
Okay, so in order to speed this up, I disconnected from the conference Wi-Fi and I'm using my cell connection. So if it's slow for you, this is one workaround that you can use, especially if you're from Europe and you can use the EU regulated data stuff. Okay, so we checked out core, and now we just move into that directory. We have to install all the composer dependencies. Configure ddev, and here it will ask us what's the project name. I'm fine with Gander, which is the folder name. It usually successfully detects like what is the root and what kind of project it is. And now we can start the environment. Now, first, I have to install the Selenium add-on that will allow me to run JavaScript tests. And now I can start it. And I will also install Drush, because I will use it to install Umami later. It's probably a good idea to have it, but you might not need it. Okay, have the environment running. I will install Drush. And at this point, we can start running tests. We do that by logging into ddev shell and then running the normal PHPUnit command. We will run a single test because these tend to, they're not the fastest one because they need to install Drupal and everything. So we won't be running all of them, just a single one for the sake of the demonstration. So I log into the ddev shell and run the test. As I said, this will take a while. So in the meantime, we can look at this test and see what it does. Which one was it? Authenticated performance test. Okay, let's hide this and this. Is it like visible enough? Can you see the code? Okay. So here we are testing front page of Umami as an authenticated user with warm cache. And obviously, depending on state of the cache, your performance metrics will be different. Your database queries will be different. Your cache sets and gets and all that will be different. So it's really important that you know in what kind of state you are testing something. And effectively, by visiting front page twice, we warm the cache. So these two steps here are warming the cache, and we are not collecting performance metrics at this step. And then here in this collect performance data closure, we visit the front page again, and we collect the performance data. And we get it as a class. How is it called? Performance data?
I think it's I think it's called performance data in the
Yeah.
namespace.
So it's a really simple class that has a bunch of attributes and getters and setters. So this is one way how you could figure out what are the performance metrics that are currently being collected. Because as core moves, we are adding more metrics to it. So it could change. Like we won't remove them because that would be PC breaking basically, but we're constantly adding them. Net just recently added like byte size of CSS and JavaScript files that are loaded on the page, which were not there before. And this allowed us to ensure that after optimizing these sizes, it stays that way. So if the size of assets on a given page will change, the test will fail, and then we will have to figure out whether the change was justified or not. And this is based on why it happened and how big the change was. Anyway, so as we can see, we are asserting on that there will be 2 style sheet files on this page that will be 44,000 bytes in size, and 1 JavaScript file that will be 125,000 bytes in size. And then we also assert that we are expecting exactly these 4 queries to run, and the test will fail if another query appears or if one of those would go away for some reason, which would probably be a good thing, but we want to know what happened. So we assert on that. We also assert on query count, which technically here wouldn't be needed because by asserting on the array itself, we already asserted that there will be 4. And then we're also asserting on cache requests and cache tag invalidations and checks and all that. And now we can go back to our test, which now successfully ran. And we can see that there were 15 assertions and that everything is okay. And now, when we've done that, we will be a little bit naughty. And we will do some change that will break something. And I want to do a change that would be impossible to catch with a standard functional test, because the functionality will stay the same, just performance will be affected. And I will do that by changing one of the views on the front page of Umami to be uncached, which is one of the things we see in our performance audits. Like when things don't work, when cache metadata is not correct, instead of fixing that like real problem, people often just disable cache, which fixes the problem, functionally speaking, but it introduces a huge performance problem. And sometimes this is not noticed because maybe website at that point didn't have a lot of traffic, but then as traffic grows or as amount of content on traffic grows, on the website grows, it can become a bigger problem. So let's do that. Let's do it here because we're using Chrome. Okay, so if I go to the front page, there's this view, which is called promoted items. And as most of views are by default, like all views by default are tag-based cached, as they should be. If I would do this and disable cache, we'll see what happens with the test. So now I've changed it in this install that I just created. Tests install Drupal from scratch, right? So in order to achieve the same change for the test, we have to change the YAML file here in the code base, which is this view. If I look for cache, we can see that we are using tag-based caching. And if I change this to none and start a test, it should fail. And the important thing here is that functionally everything is the same. There is impossible to detect this change with a functional test, unless you would go into the views UI with a functional test and assert on the views UI, but that's not the point. But the performance test will detect that because there will be more queries run on the page. And this is how you can prevent somebody from doing something stupid like this. And you can see that now the test failed. And it's complaining about the queries. And we remember from before that we had these 4 queries that we expected. Or maybe even the 4th one is different, I'm not sure. But definitely we didn't expect the 5th one. And that's how we detected this unwanted change that affects performance. This screenshot that you cannot really see, it's basically this code that I showed you before. So we went through that already. We're not missing out anything. We mentioned before that there are 2 ways of using Gander. One way is what we just saw, asserting on performance metrics and making sure that things stay in good shape. But we can also run like regular tests and collect metrics over time. For that, we need to introduce, like the first way can be done, like if you're running standard Drupal JavaScript tests, you can do the first approach without any issues. If you want to do the long-term collecting of performance metrics, we have to introduce a few more things to the stack. Because we are collecting the data and then test sends the data to OpenTelemetry, which is then eventually fed into Grafana and displayed there. And there are quite a few services that you need to do that. And in order to make your life easier, we created a DDev add-on that prepares all these services in your local DDev environment, so you don't have to think about and spend time doing it. We are also publishing Grafana configuration files for the graphs that are displayed on the dashboard that we use for core. So in order, like if you would want to set up this for your custom project and start doing this, you can use this configuration as a starting point. And let's see how it's done. So in order to start doing this, I need to add another DDev add-on, which is the Gander add-on, which adds Grafana, Prometheus, Tempo, OpenTelemetry collector, all those things that we need. We need to restart the environment because we need all these services to be configured. And then we will start tests, and we will be running them like in perpetuity, because in order for graphs to appear, you need to have a few data points, as you will see later, to actually see something.
Just to say the reason that there's the OpenTelemetry dashboard and the PHPUnit assertions is because the metrics on the dashboard are all things that we didn't want to add assertions for in PHPUnit tests. So time to first byte and largest contentful paint and things like that, those are times, and times will vary every run. So if you add an assertion, you're always going to have false negatives or false positives at some level. So rather than adding like assertions with loads of headroom that could still be wrong or not tell you when things get worse, this then allows you to see how they're doing, and it's like there's limitations because like how much of a regression over time you still might not see it, but it's more chance than zero. You can see the umami largest contentful paint was really bad a few months ago, and that stuck out really badly in the graphs. You could just see how bad it was, like a massive distance between the lines, and then like Mike Herschel fixed it, and now it's okay.
And now that we restarted the dev environment, we have Grafana on this URL. It's HTTP, so if you will put in HTTPS, it won't work like it didn't for me just a moment ago. And this is it. This is now Grafana that is running inside of your dev environment. And I already started the test, which failed because we still have the change that we did before in there. So let's revert that. Let's start it again. So now you will see after a while, when this test will be running, we will see the traces appearing here for each test and data for the metrics in the graph. But we have to wait for 2 or 3 iterations of tests to finish before we do that. And this is a nice opportunity for us to take a break because it's coffee time. Are you, like, I think that break is officially 30 minutes. We're already 5 minutes past. Are you okay if we make the break slightly shorter? Should we meet back in 15 minutes, 20 past? Is that okay? Okay. And I will keep the tests running, and when we come back, we will see how the graphs will update. Welcome back. First, does anyone need any help with anything so far? Installing the environment, running tests? Can somebody, yeah? Like, feel free to ask for help, especially because now it could get a little bit more interesting. So back to where we left things before the break. We still have these performance tests running, and now they've ran a few times, as we see. I don't know exactly how many times, but you know, enough times that we should be able to see some results in Grafana, which we do. We can see that on the graphs on the left side, there are some data points for some metrics. Largest contentful paint, first contentful paint, and time to first byte. Those are metrics that are collected on front end, and we usually don't assert on these metrics because they are not deterministic. Like, they will always vary a little bit. So it really doesn't make a lot of sense asserting on those, but they can be really useful when you're trying to figure out what is happening long term. As you can see, the data points are a little bit all over the place. And that's because I have other things running on the laptop, and the run times vary a little bit. And that's why we recommend, if you will be doing this for your own project, to have a dedicated test runner just for these tests, to have it as consistent as possible. And this is also exactly what we do for core tests. Gander dot, what's the URL? That's IO. Okay.
That should be right, but
is it down?
that's that one.
It's not working.
Is it missing HTTPS?
Nope.
Maybe it's the internet's gone.
Ah, okay. Let me try to tether again. Is the Wi-Fi that bad? No. Even when
Try
I'm...
without the HTTPS, maybe.
Yep. I just reconnected now. No. Could be down.
Yeah, it could be.
Anyway, so putting Murphy aside, so what I wanted to show you is that on the dashboard that we are running for core, these data points are more, what would be the word? More consistent.
More consistent.
Yeah.
We don't use the GitLab runners that are used for the core test ones.
Can you speak into the microphone?
So on GitLab CI you can add custom test runners. So Tag1 has donated one that only runs the performance tests. So there's one machine that always runs the same tests, that has the same configuration. I think it's still like on AWS or something, but it's like it's not being used for any other test jobs. It's only used for these, and it gives better consistency than if it would sometimes have other tests running on it. It's not perfect, but it's pretty consistent. Like, yeah.
As you will be able to see when we figure out why it's not working. And then here on the right side of the screen, you get traces for each individual run. And then if you go and inspect an individual trace, you can see all the metrics in a timeline. And as far as I understand, Nat, you were able to identify quite a few performance issues just by looking into this.
Yeah, it gives you this gives you like a browsable overview of which queries are running. So for example, Drupal core tests were creating the log table every time they logged in because no one had ever logged in before on every test install. But they weren't well, in fact, they weren't even creating it. They were checking if it existed, but not creating it because the password was always correct. It only gets created when the password is not correct, and that is something that we never knew happened on core test ones. But there's this like lock query in these traces, and I was like, I have no idea why that would be there, and then was able to like debug it and figure out where it came from. So it's like if you know. You kind of have to look at it to know what to expect, but once you know what should be in there, stuff sticks out really quickly. I mean, it's like Devel Query Log will also find you these things, but the big difference with this is like if I'm testing with Devel Query Log or like Web Profiler or XHProf, every time you want to check a change, you have to follow your like 5 steps to get to the right amount of cache warming. And the difference with this is that you do that in the test. So every time you run, you're always going to get the same queries. And the only time it will change is when something actually has changed and not just because you forgot to refresh the page once or something like that. So it makes it easier to find things that stick out that way.
But right now, just tracing I/O, right? Like everything that's output related.
Yeah, it's only IO. So what it doesn't do is like function calls and things like that you would get with XHProf. It would be possible to add that. Like you can, especially with like modern PHP, there's loads of things you could do to collect the number of function calls and show them in the traces. The problem is that when you do that, you add overhead to the test collection, so other things will then be affected because you're collecting more data. But like we should add the capability to do it because it would be a useful thing. But you might have to have like tests with and without, but there's no reason not to do that. And then we get even more granular data about what's going on. But that's a to-do, is that kind of support.
Okay. Nope. wrong slide. We've been here. We've done this. We got data into Grafana. And now we've come to a point where we will ask you to help us write some tests. There are a few performance tests in core right now. Most of them are in Umami. There's only one other that is not in Umami, that it's like testing standard installation profile, right? And some of the existing tests are missing assertions because the tests were created before the more data that is collected was added. So we have a few of those where this would be nice to add. And we would also like to add performance tests for a few pages that are not tested yet in Umami. And that's specifically admin content, so content listing, adding an article, and I think that Catch also created one for the taxonomy listing and menu UI.
Yeah, that's all of them. Yeah.
So the goal is to contribute patches to core, and let's see how that goes. There is a meta issue, which is this one, the link on the slide, that has child issues for all these things that I just mentioned. And the idea is that we split and try to do it. I will demo the first one, I guess, here on the screen, but I won't be creating a merge request necessarily, so you can also pick that issue, because I don't want to take attributions from you. I think that, like, now I will show what has to be done for the first one, but in the meanwhile, I would invite you to go and pick child issue, like one of the issues, and work on them, and maybe just leave a comment in the issue that you're working on it, so that other people know that that specific issue is taken. And as we said before, maybe collaborate in smaller groups and, do it together, review each other's work. That's the idea. Now I will go through steps for one issue here, and I don't know, you can, like, we have a few people here. Nat and I are here, and basically everybody in yellow t-shirts is here to help you. So if you are stuck with anything, just wave the hand or let us know, and we will help you. So let's see.
Oh, and just to say, the first issues that say add assertions, they have the least work involved and the most structure. But the ones where there's a new page to test, you will also need to create like your test boilerplate, because that test does not exist. It's adding a test. So depending on like how much work you want to do, that might influence your decision. But someone please choose the last three so that someone works on different things. But just like decide for yourself how much you want to take on.
Okay, so this issue is about node page performance test with cold cache, and the problem here is that the cold cache test doesn't have assertions for cache requests and database queries and JavaScript and CSS files, because this metrics didn't exist when this test was created. So the goal here is to add that. So let's look at the test. It's hard to work on. Should close this. So we are working on cold cache, and we can see that it basically doesn't do any assertions yet. It's just collecting the data. And the reason why it does that is because we wanted to collect the data for the Grafana dashboard, because this was, I guess, one of the first things that we've done with Gander, and never got to adding assertions to it. So what we would do here is we would look at one of the tests that already has assertions and basically copy paste them and fix the numbers so they represent what is happening on that page. So maybe let's pick this one. So we can see that this test here has many more assertions. I will just copy this over to this test. And now if I would run it, it would obviously fail because the metrics are different. And usually how we do that, we run it and then we fix it with the values that come out. And also consider if it makes sense for the numbers to be what they appear to be. So we could do it one by one, but since these tests run for a little bit longer time, it makes sense to just dump the entire performance data and then fix all of them in one go. And in this specific case, we are also, because we weren't doing any assertions, we were not assigning performance data to any variable, so we also have to add that. Otherwise, we won't be able to access the metrics. And now, when we will run this specific test, which was this one, we will see that it will fail because the assertions will fail, but we will also see what the metrics are. And then we will update the assertions, and then in theory, the test should come back green.
Let's see.
Any questions? And
I still think you should automate that.
I agree. It's running. So what happens to me sometimes is that tests get stuck and I have no idea why. And then I check what the CPU usage is to see if the test is actually running. And if I think that it's not running, then I restart ddev, and that usually fixes it. And I suspect that I will have to do this now. Does that happen to you ever?
Yeah, I mean, yeah, sometimes they hang, yeah. Yeah.
Okay, I'm glad I'm not the only one.
Question?
Yes.
Is the test performance affected whether you run Grafana or not? Like how fast it is for local?
There are like, yeah, if you have that add-on installed, the add-on adds a Grafana endpoint, and that will send the trace data. So there's like a network request that sends that, like when it does collect performance data, there will be one network request to the OpenTelemetry collector when you do that. But it's not that big, like, but it might not help. Yeah.
So how does it affect performance if
Do you mean the performance of the test? Oh, so the only it does a bit. So there's when the way that the performance collector works, there's two things that it collects. It collects the network data and then like backend data. So the backend data is collected by a test Drupal module that runs on the tested site, and that like logs the queries. It's a bit like what the web profiler module does in Contrib. It uses the same technique, like the database query events and things like that. And then it writes it to like key value, and then it gets it at the end. So that's like a little bit of overhead on the tested site, but everything is in memory, and it's the end of request. It's an end of request listener, so it's the minimum that I could come up with, like the minimum overhead on the tested site, so it doesn't mess up like time to first byte and things like that. But the other end is PHPUnit is getting the Chrome performance log, which is like a stream. You don't get one log for a request; it's just a stream of a log. So it has to like wait for previous requests to finish, including like image requests, which could be creating like image derivatives. Like it can take a while, so there's a couple of sleeps in there, and then it kind of tries to detect the beginning of the request that we want, and then it has to wait until all of the HTTP requests from that request have finished, like JavaScript, TypeScript, everything like that, keeps passing the log in a while loop, and then it comes out. So it's like extra 3 to 5 seconds, I would say, like the collect performance data method. So it does, like, they do take slightly longer to run. I mean, we're talking like 5 seconds longer. Yeah, like, yeah. So a normal functional JavaScript test won't even run the performance log, but now it does. So I mean, I would like, if I was gonna do like a contrib project or something like that, I would not just switch this on for every test. I would have like we've done for core, have a performance test class, so that you've only got the overhead on the class that you're actually doing this on. Like I wouldn't just like add it everywhere and then add some extra assertions, because also like what you do in a functional, like most of these don't actually do much functional things. They just like load a page or submit one form. Like you don't want like complex testing steps. I mean, you could, but generally you don't. You're doing something pretty simple to hit one interaction and then seeing what happens from that.
Yay. So this being a cold cache test, Drupal produces how many? 407 database queries for this request. So just copying that from console took some imagination. But I think that I succeeded. And now we can also update the other metrics. We have cache get count here. Where is cache get? Cache get. We have cache set count. Cache delete, it's 2. 243.81. Which one was this? Checksum valid is 81. Invalid is 0. Okay. Now the rest are on the top, because no, why not? 2 style sheets. 2 style sheets, okay. 1 script. 1 script.
Oh, one thing here. We originally started with hard numbers of the exact number of bytes for those assertions in core, and like annoyed every core developer who had to make the tiniest change to any style sheet or JavaScript file. So we, instead of doing that, we add it, like we basically round it up to the nearest 500 bytes. And that way, if you did like a small refactoring to a file, you don't have to touch the number because it's still going to be below. Whether it goes down or up, we don't care. But then someone who does a big refactor that goes up still gets caught out. And like one day, if the files get a lot smaller, like the only issue with this is it doesn't fail when you make the file smaller, so you don't record that you have. We could make it like a moreland as well. That's the thing to add, maybe, is to do that.
An idea for contribution.
Yeah, and you'd like the number is there, so you just have to add a greater than. You don't need to add any support. You can just add the assertion to tests.
Yeah, I think that I forgot to do this before. When I first ran this test, I used variable export on performance data class, which then gave me all the metrics immediately. Otherwise, I would have to go assertion by assertion. And the reason why we decided to use var export instead of var dump or anything else is because var export formats the output in a nice PHP syntax array. Otherwise, you would have to mess with, make it a real PHP array from whatever var dump would give you. And here you don't have to do that. I still had to, because it creates, it adds this numerical indexes for the queries. I had to remove that, but that was quite easy to do with a regular expression. And now, in theory, if we try to restart this test, it should pass. And that's how you write performance tests. And this is what we're trying to do now with the issues that we were talking about. Let's see if anyone picked up any issue.
If you're not logged in, it might not update. If you're not logged in that window, it might not update to tell you.
Maybe we can ask, like, did you, Benji, anyone else? Come on. Let's contribute some. Oh, we failed again. It's an interesting problem. Is it possible that the ordering of the queries will vary? Or does it, what does it use to assert?
Oh yeah, no, it's possible. So yeah, okay. This is a tricky one. So because it's a cold cache, the asset aggregates have not been created, and nor have image derivatives. Which means, because we're actually visiting the page in Chrome, those requests also occur when the performance data is collected, and the database queries from those requests also get collected by the test module which runs, because it won't empty out the queries at the end of the request. You empty the queries out when you get the data from the module, which means if you have these extra network requests, then because those can be issued in a different order, or even if it's the same order, the queries can run at a different time because the different requests are running through their steps in a different time. The easiest way to avoid that issue is not to do 100% cold cache test. So if you add a step where you visit the page and add so that it generates image derivatives and aggregates, the asset aggregates, and then clear the cache in the test, and then visit the page, those files exist on disk, and it's essentially like if you have a running site and you have like a just CR, like more or less, it gives you that. So the PHP request is cold, but the asset requests are hot. And that's more predictable when you want to collect the performance data. Like if you wanted to test the asset generation database queries, you could like delete one file and visit that URL directly. So that like you can still test those things, but it's usually better to have these like couple of cache warming steps in the test, clear as many caches as you want, and then do it. And then these kind of like artifacts of Drupal page requests that go out of contention. So what it would mean for this one is, if you look at one or two of the other tests, those steps are taken because they add assertions. I think standard performance test does that. Like it does a couple of things and then it clears the cache, like clear all, and then it collects the performance data, and that avoids the race conditions between the different requests. So like it's a problem because it's realistic, but it's a bit too realistic because it becomes hard. The other thing you can do though is just like not assert the individual queries and just assert that there's like 400 however many there is, and that should be the same every time. And if the only way it would not be is if the caches are built differently between the different requests in different orders, and that but then you learn something interesting, but you might not have a test that gets committed to call because it might have a random test failure. But in terms of like finding out what's going on, it's useful information if you see these kinds of things.
Could we sort the query array so it's always ordered the same way?
We could do that. The only issue with sorting the query array is if you're debugging and you want to see why this query is running, like, because it shows you the order that the queries ran. Like for the traces, you want to see the queries in the order that they ran and how long they took. But for the assertions, maybe we could do that instead. I mean, certainly the test could do it. The test could sort the output of the, like when it does get queries, just run sort on it, and then like that way it's not in the API, but you can do an individual test when you run into this kind of situation.
So now I commented out the specific queries assertion and just left the others, and let's see what happens.
And that's just an example of how much pain I went through getting this to work out. When I was first starting to work on it, there's so many things that go wrong.
So I think what the standard test is doing should be the helper method. That would help for this test as well.
Yeah, we could add that to the performance test trait to.
It seems to be that number of queries is varying also.
Yeah, that might be the order that the requests complete in, depending on, like, for example, a hook cache. If you have like an image derivative request before an aggregate request, certain end of request caches will get built differently, and then the next request will have more or less things in that cache, and then like the different numbers of queries will run. Or like if two things run and they both write, and like they can't use the cache item that they're all creating. So you do
Catch, if I do this, if I visit this page before I collect the metrics, and this rebuild all will clear all the caches?
Yeah.
So if I do this, then the aggregates and the
Yes.
image styles should be created.
That should work, yeah.
Okay, and now it will obviously fail because things will be different, but well, let's see what happens. But still, yeah, now we are asserting on the queries. Let's see how many there will be. Oh, I didn't save the file. That'll be useful. And also, now it's probably a good idea to export the metrics again. Okay, test seems to be running. Any other questions? We can repeat it.
Yeah.
Yeah.
What would be the best way to test that something that doesn't happen in core but can happen with config? So a complete module can do something which breaks some performance optimizations in core.
Do you have a specific example? Oh, go on then.
The alias preloading. The alias manager does preloading, and it does it if a cache key is set. And there might be cases where config, or even core mesh, can make it so that the cache key is not set.
So the question was, how would you do a test where something doesn't happen where you have stock core, but does happen when a contrib module is doing something in such a way that it causes a performance issue? And the example was that path alias preloading only runs when a certain cache item is set, but there was a core patch which broke that cache item, which caused path alias preloading to fail. Is that correct? So the way that you could do, I don't know about the patch, but the contrib module example, you could add a test module that recreates, that like does just enough of what a contrib module would do to cause the same problem, would be like my first thought. The other thing is, if you, with a core patch idea, like I don't know if we have test coverage for path alias preloading, but if we have performance test coverage that checks that the individual path alias queries, like looks for the preload path alias query and asserts the number of counts when that is in place. I'm not sure we even have path alias. There might be path aliases in Umami, but like we might be missing coverage for that functionality in core. So adding a test that explicitly requests a path that has several aliases that are rendered in such a way that the queries run, but the path alias preloading can work, that you could just add as a test scenario to core, and then the patch that broke it would break that test. And that's the kind of thing where, as we find performance regressions in core, if we can create tests for the scenario that were not tested, we not only will we not break those things again, but they will cover like certain combinations of cold and warm cache that are not already covered, or different pages as well. And the more coverage we have like that, that's based on things that have gone wrong, like the less issues we will introduce. The other thing with the contrib module is to write a test for the contrib module that uses this, and then they can run on their GitLab pipeline every time anyone submits an MR to the contrib module. So if it's like a specific, especially high use contrib modules, if you had performance tests for those, that would be great, because a lot of some real site issues are core, but a lot of them are not. It'll be like redirect module, or C tools or something like that. Yeah, this one here. Yeah, yeah.
It's failed again, but I'm not sure why. One reason is that I left the export in, so now the output is huge, and that might be the reason as well.
Yeah,
right?
that's probably why. Yeah, it'll fail just because there's output. Yeah,
Oh no, there are still some variations with queries, it seems.
In the cache warming step, did you visit the front page or did you visit a different page?
This page, the page that we are testing, like node 1.
It should be okay. It might need to be visited twice. Yeah, I would visit it twice.
Here?
Yeah. Because what is the reason?
Because it fixes it?
Yeah, well, yeah. It's like it is a bit switching it on and off again, but the especially when you have multiple requests issued by one request, actually no, there's a good reason. I just forgot what it was. So it's cache collector is the main thing. So a lot of Drupal core uses a cache collector. So when you're getting things from state, when you're getting like plugin definitions or something, we don't load like an entire huge amount of data on every request. What we do is we load we build up a partial cache of like hooks, hook implementations, or like path alias prefixes and things like that. And each request builds on that when you have a cold cache. So you start out with nothing, and then you do a request, and like the big discovery caches get built. But then the next requests after that, for example, the hook implementations in use, we only record the hooks that are actually invoked on a page. And then when you hit a different page, different hooks get invoked. And when you hit a different page, different hooks get invoked. And the list of those gets written at the end of the request after the response is sent to the browser. So when you have image derivatives and asset aggregates, you're hitting like 8 PHP requests at once. But when we write to the cache, we don't, like one of them will win. So the request that starts at the beginning and the last one to end, that will win, because later a different request will win and add those items. But they can't all add items because it's just like, that's not how it works. So by hitting it twice, you ensure that the first request, whatever wins, could be one of those asset or image requests. But the second request, those have been done. And that means that the request to the node page itself, the actual PHP request that generates the HTML page, that will be guaranteed to be the last HTTP request to finish. So that will then write cache collector items to the cache collector cache key object. And then your third request has a consistent state. Yeah, that's why.
Looks like it should be executed twice every time for each test, right? Because to get the correct result.
Yeah, I think we should add. Someone mentioned, was it you? A helper that is like set up something that's a closure, and you pass it a URL and it hits the URL twice and then clears the cache, and then you can go from that step onwards. Because even with like warm cache setups, you still want to do that without the cache clearing. So that would be a good. There's a performance test trait class. If anyone wants to take that on, that's a good issue to open. It doesn't exist yet, but it would be a good one.
Even after that, it seems that number of queries and the ordering is fluctuating a little bit. So we probably picked not the best example, because cold cache is the hardest one to do.
Yeah.
Yes?
The
Daniel has an idea. No, go ahead.
So we're using like Moshe's ultimate test trait, which is like providing the existing
So the first answer is no. There isn't yet integration for Drupal test traits, but it could be added. So there's two parts to adding it. One is that because it's performance test trait, you could add another trait. Like basically, there's a performance test trait class that has most of the work, and then there's performance test base, which extends functional JavaScript tests, which just does a little handful of things in setup that weren't easy to put in the trait. So if you made a new base class that has the performance test trait and the Drupal test trait stuff together, then you've got like, I don't know, a dozen lines of glue to make it do what, like, that you can copy from performance test base. And that would give you all of the OpenTelemetry integration out of the box because that's from Chrome. So everything that's front end, so style sheets, script files, images when it's added, there's an issue, it's not in yet. And then the time to first byte and stuff on Grafana, that will all work once those steps are done. The thing that would not work is the query collection and the cache integration, but you could write or change the existing test module to, instead of, like, it's essentially to make it work for DTT, instead of querying a database, because you can't access the database to pull the data out as easily, or you would have to like do some weird thing with the connection. If you got it to write JSON at the bottom of the page at the end of the request, like spit it out, you could then read that JSON from PHPUnit and get all of the same information. But it just makes it slightly less realistic because you're putting extra crap at the bottom of the page. But to use it on a real site, that might be the trade-off. I mean, the other way would be to put it in some location that PHPUnit can pull it from. I don't know what the best option is there, but like definitely we could add all of the things that you can do with this. Could be done with DTT, but it's like there's work involved to port it over.
We have, unfortunately, just 2 or 3 minutes left. So, yeah, that test is still failing. But we will try to figure it out, and we will open a merge request on the issue for that test, so you can come back to the issue a little bit later and see how to make it work. As promised, this is all the steps that will remove everything that we added to your environment, so you have clean working machine. And we would like to ask you to start using Gander. If you're a core developer, start writing more tests, as we were trying to do today, but we ran out of time. If you're a country maintainer, you can also start writing performance tests. Assertions will work out of the box, but if you wanted to have your own Grafana dashboard for your module, there are options to do it, and you can reach out to us and we would be happy to help. Same with the custom project, like if you find it useful, especially if you're already testing, if you're already doing automated testing on your custom project, it's quite easy to start using Gander. And if nothing else, just tell somebody about it so people know that it exists and that they can start using it. And we would like to thank you for coming.
Thank you.